Good morning, everyone. First, I would like to thank the organizing committee of the International Engineering Symposium, especially Dr. Kızılay and the Industrial Engineering Department at İzmir Democracy University for inviting me to speak as a keynote speaker. It is truly an honor. Today's talk is titled Engineering the Future of Warehousing, IL Innovation for Sustainable Digitalization. Warehousing is a fascinating topic that sits at the intersection of logistics, design, and technology. It's a domain where engineering principles can profoundly influence operational efficiency, sustainability, and even societal well-being. Before diving into the details, let me briefly introduce myself. I am Ömer Öztürkoğlu, and my academic journey has been deeply rooted in industrial and systems engineering, focusing on warehousing and logistics optimization. Over the years, I have explored innovative designs, applied artificial intelligence and digital tools, and developed optimization models for warehouses and logistics processes. These efforts reflect my broader goal to use engineering as a tool to solve complex logistical challenges, ensuring efficiency and sustainability in supply chains. Over the years, I've been fortunate to lead several projects supported by institutions like TÜBİTAK and Innovate UK. These include research on innovative IL designs, AI applications in logistics, and sustainable supply chain development. These projects have not only expanded our understanding of warehousing, but have also provided practical solutions for real-world problems. Today, I'll share some insights and findings from these projects, highlighting how engineering can transform warehousing. When I first started my research on warehousing when I was a PhD student, many people, including my friends and family members, questioned its relevance. To them, warehouses were just places to stack and store goods. So I would like to remind that this was back in 2006 and 7. They weren't entirely wrong. Warehousing was often treated as a static space. Even in our family business, we always treated our warehouse as a static space, not a space that could enhance the competitiveness of the company. But warehouses are much more than that. A warehouse is a productivity engine. It is where goods are organized, processed, and dispatched, influencing delivery speed, cost, and customer satisfaction. Engineering plays a critical role in optimizing these functions to ensure smooth operations. Then we also realize its true potential as the backbone of supply chains, driving competitiveness through efficient operations when I was doing my PhD. And nowadays, I believe that many of the operations and supply chain managers are aware of this fact. Warehouses perform essential functions: receiving goods, storage, order picking, and shipping. With the rise of e-commerce, these operations have become increasingly demanding. Customers now expect same-day deliveries, and warehouses must operate faster and more efficiently than before. This is where engineering shines. By systematically analyzing workflows and implementing innovative designs, we can reduce inefficiencies and improve throughput, making warehouses strategic assets rather than just storage spaces. Over time, warehouses have evolved across 3 generations, according to Boysen and DeCoster, 2024. The first generation was basic. Goods were manually handled in static setups. The second generation introduced extended systems accommodating greater complexity and larger volumes. And today, third generation warehouses integrate robotics and digital tools to automate processes. Additionally, warehouses are categorized as picker to parts or parts to picker systems. Picker-to-parts systems are flexible but labor-intensive, while parts-to-picker systems are more automated but require higher initial investments. As engineers, we weigh these trade-offs using data-driven approach to identify optimal warehouse configurations such as layout, storage assignment, order processing for specific needs. Most warehouses in industry still use traditional layouts. Let me use a laser pointer. In these traditional layouts, where workers move horizontally or vertically to access goods, while functional, conservative, and presenting high capacity, these layouts often result in significant travel times and operational inefficiencies. This layout is called one-block design, in which there are no middle cross aisles that could facilitate travel between picking aisles. And there are two different types of travel comments in these traditional warehouses. Mostly we call them pallet in, pallet out warehouses. This is a single comment in which we handle only one pallet in a tour. And this is dual comment. We do handle two pallets in one comment. So here is a question. Why more than 99% of the warehouses in industry looks like this type of traditional layout? Is there no other way to design these warehouses so that we can reduce single or dual comment travel distances, so we can improve picking operation, increase productivity, save energy cost, and even reduce carbon footprint? Back in 2009, Gu and Meller actually relaxed the unspoken design assumptions of traditional unit load warehouses and proposed flying V and fishbone non-traditional aisle designs with a reduction of up to 10% by flying V and 10% by fishbone on single comment travel distance. The idea behind of their designs, as you see in these figures, that the close, as you know, that the shortest distance between 2 points is a straight line. So the idea behind of their designs is closer to Euclidean distance, the shorter the travel in a warehouse. So these layouts apply critical engineering principles, geometry, optimization, and simulation to improve operational efficiency. Building on their research, our research introduced optimal designs like chevron with one cross aisle that produces as efficient operation as in fishbone. We actually showed that fishbone and chevron are dual designs using mathematical expressions for travel distance calculations. Doesn't chevron look so natural, like the leaves? I think it does. For the second and third designs we proposed, we call them leaf and butterfly, inspired by their natural patterns. These sort of mimic the flow structures seen in nature to optimize material movement in warehouses. Isn't it fascinating how natural forms can inform optimal engineering solutions? Yeah, nature often offers elegant solutions. Although our research was inductive, the patterns we observe in leaves and rivers can inform that we can take deductive approach and Hence, we can note that these designs reflect a fundamental engineering mindset, learn from systems that already work, like nature, and adapt them to solve practical problems. Here is an example demonstration of the closed form travel distance functions for the leaf. To gain meaningful insights, we compared the impacts of these chevron, leaf, and butterfly new aisle designs on travel distance and storage space efficiency. This is for expected travel distance comparison, and this is for percentage increase in area in comparison to traditional layouts. Optimal designs can reduce travel distance by 13% to 20% compared to one block layout, but require 3 to 25% more space due to additional cross and angled aisles. This highlights a common trade-off: operational efficiency versus storage capacity. While reduced travel saves labor and energy, it comes at the cost of larger construction and land requirements. This is why data-driven engineering is essential. Decisions like these carry significant economic, environmental, and social impacts. With the right analysis, we can balance these trade-offs and create sustainable and high-performing systems. To cover some other practical features, we consider different number and locations of P&D points in other design problems. As you see that the flows in this type of warehouse go through the bottom input-output points. So this is another configuration. And in the last configuration, there are flows from all around the warehouse. This problem is actually more complex. Therefore, to be able to handle the more complex scenarios, we developed decision support systems that rely on AI and graph-based modeling. These systems evaluate layouts against cost functions, incorporating practical constraints like multiple pickup and deposit points and different storage policies. Think about it. Instead of trial and error, these systems simulate thousands of scenarios to identify the optimal layout, saving time, money, and effort. This is engineering at its finest, combining data, algorithms, and practical insights to make informed decisions. Here is a quick demonstrations. Here's a quick demonstration of the algorithm. Unfortunately, it doesn't run at the moment. Let me try to figure out how can I run it. Here it is. This is how the model runs and search for the optimal designs based on the given configurations. Hence, we can search for infinite number of potential designs. So these optimal designs showcase multiple input-output points as we described before. For each problem, these are the optimal designs with 2 cross aisles, representing different flow patterns within warehouses. And unfortunately, the same trade-off between operational efficiency and storage, extra storage capacity requirement is evident here as well. Interestingly, this study also highlights that conventional warehouse layouts tend to perform best when flows are evenly distributed across all areas of the warehouse. We also investigated the robustness of some of these design for varying number of P&D points and storage policies. As the demand for e-commerce continues to grow and short delivery time commitments become standard, warehouse managers and workers face increasing challenge. They must handle a higher volume of orders consisting of small packages or units and multiple items from various customers. This makes the efficiency of order picking operations crucial. As workers navigate multiple locations within the warehouse, similar to how we move through supermarkets while shopping, this raises an important question for us. Are there better layout designs than the conventional ones for warehouses or storage spaces where order picking operations are particularly intensive? To explore this, we developed several innovative design ideas. As you see in these figures, these are the ideas we developed. And using this decision support system we developed previously under the support of TÜBİTAK projects, we'll look for the optimal designs for each design problem. In this figure, you see a demonstration of an optimal tool for an order picker in a warehouse with tunnels, showcasing the strategically designed tunnel locations. These designs differ from conventional layouts by placing tunnels along each picking aisle or segments of a linear cross aisle at optimized locations. This arrangement facilitates easier access to neighboring aisles and significantly reduces travel distances while maintaining storage capacity equivalent to a traditional warehouse. So these are some other solutions for different number of picks and number of aisles. By redesigning aisle layouts with strategically placed tunnels, we achieved up to 15% savings in travel distances compared to one block warehouse and up to 7% in comparison to two block warehouses without any loss in storage capacity. Imagine the cumulative savings for warehouses processing thousands of orders daily. This even 6-7% may create significant savings. In another design problem, which looks for X-shape designs, we found that there is actually no significant improvement over conventional layouts in terms of efficiency. This is primarily due to the excessive loss of storage capacity associated with this X design. This is another findings we learned from our research. So these innovative layouts, these new aisle designs have been implemented in various settings, including pallet in, pallet out warehouses and floor stacking facilities. Most of the implementations, as far as we know, appeared in the US. Let's have a look at some of these example implementations. This example comes from a pallet in, pallet out warehouse designed to store mobile generators on pallets. As shown, the layout features angled cross aisles, resembling a fishbone design. This is another picture from the same warehouse. This is an application in a floor stacking warehouse with varying lane depths. Since there are no racks, this setup requires no significant investment in racking systems. Additionally, the layout is highly flexible. It can be reorganized or adjusted immediately as needed. Such warehouses can also be seen in construction materials and white goods manufacturing facilities. This is a real picture from the same warehouse, and this is another picture from the same warehouse. For these two implementations from the workers in the field, we received some interesting feedback regarding the use of angled aisles. While forklift drivers make a 135-degree turn when exiting a picking aisle, they still have to look both ways before entering a cross aisle, sometimes requiring, as you can imagine, that them to look back 135 degrees, which can be cumbersome. To address this safety concern, semi-hemispherical mirrors were installed at these intersections. On the other hand, workers at another warehouse shared a surprising benefit. They said they appreciated the design because it allowed them to take 45-degree turns at full throttle, significantly improving their efficiency, an advantage we hadn't anticipated. This feedback highlights how engineering solutions can align with human needs, making operations not just efficient but enjoyable. This is another example from manufacturing storage space with floor stacking. Similar to previous one, this setup also features floor stacking, but it is specifically designed for furniture storage. And this is the latest application I have heard so far, which comes from one of the largest logistics companies' distribution center in the United States. So beyond traditional warehouses, these new aisle design ideas have potential applications in container yards for straddle crane terminals and unconventional storage facilities. By optimizing layout in these spaces, we can improve throughput and reduce idle times for machinery, demonstrating the versatility of engineering-driven solutions. This is another demonstration which was developed by my former colleague, Goran. Let's talk about sustainable digitalization in warehouses. Warehouses are undergoing rapid transformation, driven by advancement in technology and evolving legislative requirements focusing on sustainability and circularity. While there are still many areas for improvement, warehouses are adapting quickly due to the repetitive nature of tasks and well-defined processes. Today, warehousing is now a hub for emerging technologies like AI, AR, augmented reality, extended reality, and robotics. We see applications of nearly all emerging technologies in warehouse operations. For instance, AI-driven optimization can batch orders more efficiently, while augmented reality glasses guide workers along optimal paths, or others, automated storage and retrieval systems, robotic pickers and loaders, collaborative robots, cobots, voice picking technology, pick to light or put to light systems, 3D high density robotic storage solutions, and even AI swarm equipment in warehouses. Notably, even cutting edge patents such as underwater storage and beehive-like warehouses proposed by Amazon, are paving the way for innovation. Each of these advancements contributes to, significantly to operational and storage efficiencies. These technologies automate repetitive tasks, enhance ergonomic and safety issues faced by human pickers, reduce operational errors, and improve overall productivity and accuracy within the warehouse environment. These are automated guided vehicles, or sometimes we can see them autonomous guided vehicles used in parts to picker warehouses. Since Amazon acquired Kiva robots, the company has deployed more than 750,000 robots in its distribution centers as of 2023. I got a chance to visit one of their distribution centers in the UK. I mean, the application looks amazing. Interestingly, these robots primarily operate in conventionally designed layouts, showcasing their adaptability to traditional warehouse structures, like in a grid. However, a recently published study highlights that fishbone layouts reduces the travel distance for robots by 18 to 28% compared to traditional arrangements, even though it comes at the cost of a 3 to 8% reduction in storage capacity. The reduction in travel distance, 18 to 28%, directly lowers energy consumption, making operations more sustainable. Additionally, minimizing redundant movements reduces wear and tear on robotic components, extending their lifespan and decreasing waste. With the introduction of new aisle designs, fishbone, chevron, or tunnel-based discrete aisle designs, one of the main critiques has been the challenge of workers following optimal tours or paths in warehouses. Without adherence to these optimized routes, as you can imagine, the benefits of new designs cannot be fully realized because workers often deviate from the paths due to various reasons. However, augmented reality or extended reality glasses is revolutionizing navigation and training in warehouses. Imagine workers seamlessly guided through complex layouts with real-time instructions like turn right, turn left, turn back. This not only reduces travel times, but also enhances accuracy and reduces stress, making the workplace more human-centric. Large companies leverage these tools to train workers effectively, offering immersive and interactive learning experiences. Interestingly, a former colleague, Dr. Özden, even developed an augmented reality-based system to assess workers' adaptability to navigating angled aisles. As you can see in this demonstration, they are actually navigating in angled aisles in leaf layout. They assess the workers' adaptability to provide valuable insights into worker efficiency and comfort in these innovative layouts. Even without requiring advanced technologies, we demonstrated that a simple raisable turntable can reduce picking time by about 7% and loading and unloading time by 20%. This highlights how small practical innovations can have a significant impact on warehousing efficiency as well as human workers' safety and ergonomic conditions. Back in 2006 or 7, my supervisors, Kevin Gu and Russ Meller, in a meeting with a warehouse and material handling professionals, they asked who wants to let their kids work in warehouses. Surprisingly, none of the managers raised their hands. Due to stress, cold environment, and repetitive and sometimes heavy works, the labor turnover has always been high in warehouses. This is why we see more sustainable digitalization practices in warehouses. And one I would like to share, one of the most remarkable examples of a human-centric warehouse initiative, which is found in Walgreens pharmaceutical warehouse in the US. These warehouses are uniquely designed to accommodate workers with disabilities with an impressive 67% of the workforce comprising individuals who are physically or mentally challenged. The facilities include flexible workstations, wheelchair ramps, elevators, touch screens for vision impaired workers, pick to light systems, voice picking systems, and all other digital tools, all aimed at creating a supportive and inclusive work environment. With strong collaboration between workers and managers, combined with appropriate training, this initiative has led to higher productivity levels than some of Walgreens' other distribution centers. It stands as a shining example of how thoughtful design and inclusion can create not just sustainable but exceptionally effective workplaces. To enhance sustainable and human-centric warehouses, we also provided a roadmap as can be seen here. To conclude, engineering plays a pivotal role in transforming warehouses into hubs of efficiency, sustainability, and inclusivity. As we move toward fully automated warehousing systems, we must also ensure that human values remain central to these advancements. Now, I would like to leave you with this question. How can we ensure that warehouses of tomorrow balance the efficiency of machine equipment and technology with the adaptability and creativity of human workers? Thank you, and I wish you all a productive and enlightening conference. Have a nice day.